Hi, this is Kona, and we're going to talk about one proportion hypothesis testing. So first of all, it's used to determine whether the proportion or percentage of one group is different from a hypothesized proportion. Normally, and especially in this class, the hypothesized proportion is going to come from a source. So some kind of news article, some kind of article, website is going to have conducted a survey and gotten a certain result on a survey question. That percentage is going to be what the hypothesized proportion or hypothesized claim value that you're going to test against when you do your one proportion hypothesis testing. So basically you're trying to figure out is the data we collected different from a hypothesized proportion? And normally, like I said, that proportion comes from a specific source, which is why you're trying to test against it to see if yours is different, more, less, whatever. It does use categorical data, which is collected from one group. Remember, categorical is names or labels without meaningful order of magnitude. So it's a yes or a no. It's did people who were released from jail go back to jail, or did they stay out of jail? You know, so it's a category. It's not anything with any real actual number value. The assumptions are that the data comes from a random sample, so it's independent, and that your successes and failures are greater than or equal to 10. Remember, successes and failures, so in the prison example, success would be that they didn't go back to jail, a failure would be that they did go to jail. For your null and alternative hypotheses, now these are important because these are the wording that you could use for claims. So if you're trying to write your own claim, say maybe for a project or something, these are the wordings you would use. Normally people write it in terms of the alternative hypothesis. So the percent of the group is not equal or is different from the claim value. The percent of the group is greater than the claim value. The percent of the group is less than the claim value. So normally you would want to use one of these as your claim. And then this would be your, and also here's something, the complement. The complement to this hypothesis is this hypothesis. The complement of this one is this one, and this one. So they go together. You cannot mix and match them. Something else that's important to remember, which tail. So for this one is not equal or is equal. That's a both tail. The percent of the group is greater than. A greater than is a right tail. And the percent of the group is less than is left tail. And remember, we get the tail from the alternative hypothesis. So even though you need the complement, you need to know what the alternative and the null is, whenever you're asked which tail that claim is, it's always going to come from your alternative hypothesis, which is why the less than is your left tail. Greater than right, and not equal or different is both. So here's a scenario just to kind of make sure you're thinking about things and understand it. A national survey was conducted that said 25% of all people believe a third-party candidate should be on the ballot. The response could be a yes or no. So yes, I think a third-party candidate should be on the ballot. No, I don't. A survey was conducted at Richland that asked the same question, and we want to know if these results are the same as the national survey. So that's our scenario. So what is the claim variable? So hypothesize and the hypothesized proportion. So the claim variable is whether the third-party candidate should be on the ballot. So that's what we're trying to figure out. Should that third-party candidate be on the ballot, yes or no? So yes or no are our answer options. And our hypothesized proportion is that 25% or 0.25. So what is the actual claim? The actual claim, we go down to a survey was conducted at Richland, blah, 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 and we want to know. So here's the actual claim from all of this. If these results are the same as the national survey, so then you write that as a claim. So if it's the same, right? So here it's not equal. Well, that's not it. Here is equal. That would be is the same, right? Is same. Okay. So whether the third-party candidate should be on the ballot. So this one, the percent of people at Richland who think a third-party candidate should be on the ballot is 25% or 0.25. And that's the equal to. So is 0.25. And that's what we want to know if they are the same, which the same would be is 0.25. Is it the null or alternative? Because it's the is, we want to know if they're the same. It's this one right here. So this is the actual hypothesis we're testing against, or we're That's our initial one, so it is the null hypothesis. The complement would be then this one right here. So the percent of people at Richland who think a third-party candidate should be on the ballot is not equal to, or is different from, 0.25. And which tail is being tested? Well, for that one, so we started here, got our complement, and then both tails are being tested. All right, so follow-up. Using the same data that was collected from the above scenario, we want to know if more than 30% of Richland students believe a third-party candidate should be on the ballot. So what is a claim variable? Well, it's still the third-party candidate, whether they should be on the ballot or not, but this time the hypothesized proportion is the 0.30. It's that 30%. What's the claim? So the claim for this time is the percent of people at Richland who think a third-party candidate should be on the ballot is more than 0.30. Because we want to know Richland's believe there should be if more than. So here's that part, if more than 30%. So that's why is more than 30%. Okay, so is it the null or alternative? Well, because there's no equality talked about there, it's going to be this one right here. So this is the hypothesis for this one. So it's alternative. So to get to what your complement is, you come across the complement is the percent of the group is less than or equal to. So here, notice the percent blah, blah, blah is less than or equal to. So you have to have both parts, not just less than, because a less than is an alternative, and you need to turn it into a null complement. And then which tail is being tested? Well, since we started here, our complement is this one, and our tail is right. So there you go. I hope that helps.